This lecture is one of the most important lectures of the entire course, so don't miss it. If you are able to understand what I'm talking about in this lecture, I'm pretty sure you will succeed with Python. So I'm going to talk about the anatomy of the Python programming language. Part of this video will be a summary of what you have learned so far. So I'll be going over the concepts you have learned and review them and explain them from another perspective so that you can see things from a different angle. Let's start. The first thing I want you to understand is that a program is like a place in the real world. Let's say a cafe. Things happen in a program, things happen in a cafe. In the program, you are the programmer. In the cafe, it's again you who orders a coffee, who orders a salad, etc. For example, to order a coffee in the cafe, you use the order coffee function, so to say. To order a list of to-do items in the program, you use the get to-dos function. You tell the function the to-dos.txt file as a string. In the case of ordering a coffee, you tell this function that you want a coffee. You tell if it's going to be a short coffee or long. And maybe you tell this function how many coffees you want. Let's say you want 2. So far so good, this is clear. Now here is the thing, and this is about understanding what actually types are in Python. So data types, I've been talking about data types, but you can also refer to them as types. This to-dos function gives us a list of to-dos. So first to-do, second to-do item, etc. While this function here gives us a coffee. Maybe in the cafe you also use other functions such as the pay function. As input you give money. As output you get a receipt. Maybe you also use another function such as clean the table. So you ask for a clean service from the waiter, and in this case you don't get an output. Same here, we have this write to do's function. This also doesn't give us an output. As you see, we are not returning anything in here as we do in the get to do's function. So this get to do's functions gives us an instance of a list. Now here's where you should make the distinction. I said an instance of a list, not a list itself. We usually say this gives us a list, but the list itself is an abstract concept. The same is for coffee or receipt. So all these are abstract concepts. The actual objects are this instance that we got here, the receipt, which says probably 10 euros or $10. This coffee is an instance. Also, the coffee could be bitter, could be warmer sometimes, could be hotter other times. So there are different instances of coffee. The concept itself this one here is just an abstract in our minds. Same goes for receipt, same goes for list. So saying that I'm drinking a coffee or I'm buying a pen is technically wrong. What we should be saying is I'm drinking an instance of a coffee or I'm buying an instance of a pen. You can say I invented the pen. That could make sense. You invented the pen concept. And then people buy instances of that pen. So these concepts in Python are also called classes. So types or classes. Types or classes are used interchangeably, two terms. So you can say this is a type, but you can also say this is a class. So it is a blueprint, just like coffee is a blueprint in our minds, and we know how to make instances of coffee by having that coffee in our mind, that abstract concept in our minds. So same goes for lists and same goes for strings. Another example, we implemented this parse function. So that is another example of a function in programming. This parse function got a string such as 6 feet 12 inches and it returned a dictionary instance with keys and values. So dictionaries are also instances of this dictionary class. So just like we have different types of classes in the real world, such as coffee, receipt, we have different types of classes in a program. By the way, this here, when you say coffee or when you say short or when you say two, these are also instances. So coffee, this here is an instance of speech, you can say, or you can say words. So just like we have a string here, a string is also a class, and this is an instance of a string to do's.txt. This is also an instance of a word or a speech, you can say. And the number is also an instance of a word. So you give words to this function, order coffee, and you get an actual cup of coffee, an instance of the coffee class. Now, all these instances, so this coffee or another coffee, they all have their own methods. So you can drink a coffee, you can sweeten it. Receipts also have their own methods. Perhaps later you can get a refund using that receipt. Perhaps you can deduct taxes using that receipt if you are self-employed or so on. And we have the same things for objects in Python in a program. So a list have an append method, have a pop method, etc. Strings also have their own methods. Dictionaries also have their own methods. So the function, for example, if we see in main.py, if we see this getToDo's function, this function, when we call it, gives us the list, and then we store the list in this toDo's variable. Now variables in the real world could be just the plate where you place that instance, that object instance. So the plate where you place that coffee cup, that could be the variable. The receipt can also be placed in a small plate. Sometimes objects are not placed in plates, as you see, for example, add here is not associated with any variable. So variables can be optional. Sometimes you need them, sometimes you don't need them. So once we get that list instance is returned from this function, and then we can use that returned object in other parts of the code. Similarly with this coffee in here. So once this order coffee function gives us the coffee cup, then we can drink it, we can sweeten it by adding sugar to it, and so on. So the order coffee is the process which makes that object instance. Now the big question is, who designs these classes? Who designs a list? Who designs a dictionary? Can you design a new class? So a blueprint. Well, we can ask the same question in the real world. Who designed the coffee? Who designed the receipt? Can you design a coffee or a new object? Can you design something new, some blueprints, which other people can use then to make instances of it? Of course, in the real world you can do it. It's not easy, but you can do it. And the same exact answer is given for the program. So you can actually design new classes and then use those classes to create instances, different instances. But why would you design a class? Well, let's say that you want to create a graphical user interface with buttons and text boxes. So in that case, you first would have to design a class, a blueprint, define the methods in that blueprint, and then use that class to create actual windows. And you do the same for buttons. You would write a class for a button and then have that class create buttons. But there are two things you should know about designing a new class. First is that most of the time these classes have been designed by other programmers, so all you have to do is just use them to create instances. So just like we had the case with lists and dictionaries and strings, these are already designed. We can just create instances of them. However, I'm going to cover how to create classes later in the course, and we're going to go a lot in depth. So basically you're going to be the god of your programs. You're going to design objects and then you're going to create object instances from your blueprints, from your classes. So those are the two things I wanted to tell you, that most of the time other people have designed these things, classes, and the second was that you're going to learn how to design them in the course later on. Therefore, classes still remain a mystery for now, and that's completely fine. Methods also remain a mystery for you, so you know how function blueprints look like, but you still don't know how class blueprints and method blueprints look like. So far we have used functions as we did here with getToDo's parentheses. So that's how you use that function. And then we also saw methods such as the append methods. You use it here, but you still haven't seen how these methods are from the inside, the blueprint of a method. So the key concept to take from this video was the distinction between classes or types, in other words, and the instances that these classes create. If you understand that difference in your mind, then you are in good tracks. So that was about the anatomy of Python. Thanks a lot, and let's do some more videos. See you.